Welcome to this deep dive. Today we're diving into something that kind of makes you question reality.
Yeah.
AI rediscovering the laws of physics. I
Wow.
mean, we're talking like Copernicus, Newton,
Right.
even quantum mechanics, but figured out by a computer.
Yeah.
You sent in some research on this, and honestly, I'm a little intimidated,
Yeah.
also super curious.
It's definitely mind-blowing stuff.
Yeah.
This research team basically built an AI that learns like we do when studying physics.
Okay.
They wanted to see if it could find like the hidden laws in data, even if it didn't know the equations beforehand.
Okay, so it's not just crunching numbers. It's
Right.
like understand.
Exactly.
This paper focuses on SciNet
Yes.
and how it finds both the physics concepts and the equations behind them.
Right.
I'm all ears. How does this even work?
So think of it like a detective,
Okay.
but instead of fingerprints and clues, it's got data.
Data.
Things like positions of planets over time.
Gotcha.
Or how tiny particles act in a magnetic field. SciNet uses two tools to make sense of this:
Okay.
variational autoencoders and neural ODEs.
Those sound intense.
They are powerful tools.
I'm guessing this is where my brain starts to melt.
Stay with me. It's not as bad as it sounds.
Okay.
Imagine trying to figure out a recipe just by taste. The variational autoencoder is kind of like that. It sifts through the data and finds the essential ingredients, the core concepts of what's going on.
Okay.
Then the neural ODEs come in. They're the pattern matchers.
Yeah, okay.
They try to find the equations that explain how those concepts change over time.
So it's finding the recipe, A and D, writing down the instructions.
Yeah.
Okay, this is already blowing my mind, but the paper gives some real-world examples, like Copernicus figuring out the solar system. The AI only had data from Earth, yet it still figured out the sun was the center.
I know.
I need you to explain this like I'm 5.
Okay, so the researchers gave the AI weekly observations of Mars and the sun,
Okay.
but only from Earth's perspective,
Okay.
just like Copernicus had. The crazy part, the AI found 2 hidden variables that changed at a steady rate. And guess what those variables were? The heliocentric angles of Earth and Mars.
What?
It basically proved the planets orbit the sun all on its own.
Hold up. It cracked the code of the solar system just from looking at Mars and the sun from Earth.
Pretty incredible.
That's next level. But then it tackled Newton's law of gravitation.
Uh-huh.
Now that feels like a whole other beast.
Totally. This time they fed the AI the distances between 2 objects over time.
Okay.
And they added a twist.
Yeah.
They gave it control over the initial distance.
Okay.
Like asking, what happens if we start these objects further apart?
So it was basically running simulations with different starting points.
Exactly.
Okay.
And get this, using some fancy math called second-order differential equations.
Right.
It found that the object's motion depends on their distance and velocity.
Uh-huh.
You know what that means? It basically nailed the inverse square law, the fundamental law behind gravity.
Wait, so it didn't just find a pattern. It figured out the relationship between distance, mass, and gravity,
Yeah.
all without ever being told about Newton's law.
Right.
I am seriously questioning if this AI is smarter than me right now.
It definitely makes you think, but hold on to your hat.
Yeah.
Because next, they threw it into the deep end, quantum mechanics.
Oh, boy.
We're talking the Schrödinger equation and the Pauli equation stuff that governs how particles act at the tiniest level.
Okay.
Even for us humans, this is mind-bending stuff.
Okay, even I know quantum mechanics is crazy complicated.
Right.
No way the AI can handle that, right?
Get ready for this. They gave the AI data representing the density of quantum particles in different potential fields.
Okay.
And just like before, gave it some control over the fields to play with.
Okay, I'm on the edge of my seat. What did it find? Spill the quantum tea.
First, the Schrödinger equation. The AI working in its 2D world and using those second-order differential equations again,
Okay.
found the key concepts. But it gets better. It figured out the equation that links those concepts to the potential field.
No way.
It essentially learned the language of quantum mechanics.
Okay, that's insane. What about the Pauli equation?
Right?
That one's even weirder. It deals with particle spin, right?
Yeah, spin is a tricky one.
Yeah.
But the AI was up for the challenge.
Yeah.
It needed 4 key variables to make sense of it.
Okay.
And even with limited data, Only the overall density, not individual spin states.
Okay.
It managed to figure out the core principles.
Hold on. So even with love's information, it still found the core ideas.
I know.
This is seriously impressive.
Yes.
But the paper mentions there are some limits.
Right.
They call it the curse of length, where the AI struggles with really long timescales.
Yeah.
So even AI gets tired.
Well, it's more that many AI models have trouble with super complex systems over long periods.
Okay.
But they're working on ways to overcome that
Okay.
by breaking the problem down or using new techniques.
So there's room for improvement. But even with limits, this is a huge leap forward.
Absolutely.
Are we on the verge of AI physicists taking over the world?
Not quite yet. But this research is pointing us towards some exciting possibilities.
Yeah.
Imagine AI analyzing data from telescopes or particle colliders, potentially leading to discoveries we haven't even dreamed of yet.
All right, before my head explodes from all this,
Yeah.
let's take a breath and talk about the implications of all this.
Okay.
It's mind-blowing, but is it all good news?
Right.
That's what we'll dig into next.
Sounds good. It's like we've given a powerful new telescope to a curious kid who knows what they'll find.
That's a great analogy,
Right.
but it also makes me wonder, is it all sunshine and roses?
Yeah.
What happens if this AI stumbles onto something we don't fully understand?
Right.
Something that could be misused?
I'm getting some sci-fi vibes here.
It's a valid question.
Yeah.
It's like any powerful tool, it can be used for good or bad.
Right.
But the potential benefits are huge.
Yeah.
Think faster drug discovery.
Right. More efficient energy? Maybe even understanding the universe in ways we can't even imagine right now.
So it's not about replacing scientists, it's about giving them a superpower.
Exactly.
Yeah.
AI can handle the boring stuff, analyze mountains of data,
Yeah.
and even suggest new research directions.
Yeah.
But it's still us humans who have to interpret the results,
Right.
ask the right questions, and make sure it's used responsibly.
Like a partnership then. Human intuition meets AI's processing power.
I like that. The best of both worlds.
Okay.
But there are challenges, no
Yeah.
doubt.
Right.
One of the big ones is making sure the AI isn't limited by the data we feed it.
Okay.
If the data is flawed,
Yeah.
the AI's conclusions could be too.
So it's not just about the AI, it's about the quality of the ingredients.
Right.
Like teaching a chef with bad produce, the meal won't be great no matter how skilled they are.
Perfect analogy.
Yeah.
We need to make sure the data is diverse, representative, and as unbiased as possible.
Right.
And we need to be transparent about the AI's limits. It's a tool, not a magic crystal ball.
This is starting to feel pretty philosophical.
Yes.
Like AI is forcing us to rethink how we do science, even what it means to understand the universe.
Absolutely. It's not just about the tech. It's about the big questions.
Yeah.
Where does knowledge come from?
Right.
What's the role of humans in discovery?
Okay.
This research is pushing us to confront those questions head on.
So for our listener who's maybe feeling overwhelmed by all this,
Right?
what's the key takeaway? Should we be excited, terrified, or both?
I'd say be consciously optimistic. This is a young field, but the potential is enormous.
Yeah.
And honestly, the fact that AI can rediscover these fundamental laws is pretty darn awe-inspiring.
I'm definitely feeling the awe mixed with a little bit of healthy skepticism.
Duh.
But that's the fun of it, right? This stuff is pushing the boundaries of what we thought was possible.
Absolutely.
Before we go full sci-fi on this, let's bring it back down to earth.
Okay.
What can our listeners actually do if they want to get involved in this world of AI and physics? All right, let's get practical. Say our listener is hearing all this and thinking, okay, this is cool, but where do I sit in? What advice would you give them?
Well, the good news is you don't need to be a coding genius or have a physics degree to get involved.
Okay.
There are tons of ways to dip your toes into this world.
Like what? Give us the goods.
First off, learning.
Okay.
There are so many online courses out there, from basic intros to more advanced stuff.
Right.
Platforms like Coursera and edX have some amazing resources, and a lot of them are totally free.
Yeah, I've dabbled in some of those myself. It's amazing how accessible they've made this stuff. You can learn about AI,
Right.
machine learning, even quantum mechanics, all from your couch.
Exactly. And if you're more of a hands-on learner,
Okay.
check out open source projects.
Oh.
Sites like GitHub are full of collaborative projects where you can contribute code,
Right.
test algorithms, or even just give feedback.
That's a good point. It's like a giant sandbox for anyone who wants to play and learn. Plus, I bet it's a great way to meet other people who are passionate about this stuff.
Absolutely. The communities are super welcoming, and they're always looking for people with different skills and perspectives.
Yeah.
It's a win-win. You learn new stuff and contribute to cutting-edge research.
So you can learn by doing and connect with a whole community. That's pretty awesome. But let's say our listener is feeling extra ambitious.
Okay.
Can they actually try building their own AI models?
You'd be surprised how easy it is to get started.
Really?
There are tools like TensorFlow and PyTorch that are surprisingly user-friendly,
Huh.
even if you don't have a ton of coding experience.
Oh.
It's like having a virtual lab right on your computer.
It's kind of like those video games where you can build anything you want because instead of building a castle, you're building an AI that could potentially unlock the secrets of the universe.
I like that analogy.
Yeah.
And hey, you never know. You might just make the next big breakthrough. But even if you don't end up building your own AI, there's still plenty of ways to get involved.
Like what? Spill the beans?
Citizen science projects.
Okay.
There are tons of projects out there that use crowdsourced data to study everything from galaxies to proteins to climate change.
Wow.
It's a way to contribute to real scientific research, even if you don't have a fancy degree.
It's like being part of a giant science fair where everyone is working together to solve these massive puzzles.
Exactly. It's a great way to satisfy your curiosity, learn new things, and make a real difference.
Yeah.
And that's really the point I hope our listener takes away from this.
Yeah.
AI and physics aren't just for the elite anymore.
Right.
It's becoming more accessible and democratic every day.
It's like the playing field is leveling and anyone with curiosity and passion can get in the game.
Exactly.
That's pretty exciting, right?
I think so. It's like we're at the beginning of a new era of discovery, and it's open to everyone.
So, to our listener out there, if this conversation has sparked something in information, don't ignore it. Dive in, explore, learn, and who knows, maybe you'll be the one to rewrite the laws of physics next.
Or maybe just rewrite your own understanding of how the world works. That's pretty powerful, too.
Well said. And on that note, I think it's time to wrap up this deep dive. It's been a wild ride, and I don't know about you, but my brain is officially full.
Mine, too.
Yeah.
But it's a good kind of full. The kind that makes you want to keep learning and exploring.
Exactly. So to our amazing listeners, keep those brains buzzing, and we'll catch you on the next deep dive.